So let's take a look at part 2 for day 8 of Advent of Code. In the first part, we were able to track down the infinite loop that was in the boot code of this kid's Game Boy. And now we're going to see if we can fix the corrupted instruction. So what we're going to have to do there is either change a jump to a no-op or change a no-op to a jump such that the boot code is able to run from start to finish and not end up in an infinite loop. Let's see if there's anything else here. I mean, just as an example, with the initial sample input, if we were to change this jump instruction to a no-op, it would allow the whole thing to complete with a global accumulator score of 8. So we might start off and see if we can get a solution with this starter input that gets us to 8, and then move on to the full puzzle input. So let's copy over part 1, part 2.ruby, because I think we can reuse most of this. And we'll change this to sample to get us started. And yeah, I think all the parsing code is the same. Yeah, I feel good about all that. I think what changes is now we're not looking for the accumulator once we've found the loop. In fact, if we've found an infinite loop, we want to raise some sort of error saying loop detected, infinite loop detected. And so if we let's make this a little simpler and say class infinite loop error, standard error, and we'll just raise that then. Okay, that'll make things a little bit easier to catch on, so we can look for that specifically. So yeah, that was kind of my initial thought, but I guess more to the core of the problem is we've got this list of instructions, and we're gonna have to go through one by one and say well, what if this no-op were instead a jump, and then see if we can execute things. What if this accumulators we're not dealing with, what if this jump were a no-op? Now, I guess if we have a jump plus 0, that essentially acts like a no-op, right? I'm kind of curious, are there no-ops that... Okay, there are no-ops with plus values. Okay. I was just checking that because I was concerned that all of the no-ops were going to be plus 0 like that, but that's not the case. So let's jump back to our file here. So yeah, we'll go one by one and just change jumps to no-ops or no-ops to jumps until we find a version of the boot code that can run to completion. That's a bit of a brute force approach, but I think that's going to be fine. I think it's going to be performant enough, and I'm not seeing there's not a more sophisticated, clever approach that's jumping out to me that would allow us to not have to brute force this. Not going to do some sort of analysis of the of the structure of this of the jumping structure. I'm sure there's a path traversal we could do there, but I think this is just going to be easier to brute force the whole thing. So I guess, yeah, so what's our base case then? I guess if we get to, if we get to here and our position right? So we're working with like positions in an array basically. So if our position is equal to the instructions.size, yeah, I guess that's fine because that's an array up here. So if our position has like reached the size, so if we're that means we've like kind of crossed the end. So that this is going to be kind of size minus 1 is this position. So then if we've advanced beyond that, then there's nowhere else to go. We can consider that we haven't hit an infinite loop, but that our boot code was actually able to run to completion, in which case we will return the accumulator. Otherwise, we'll just keep looping and traversing the thing. So that's cool, that works. So yeah, we're gonna have to take this this instructions by position, and we're gonna want to, let's see. Yeah, we'll do instructions by position, and we'll just say for each map. Can we map over a? Yeah, we'll map over this, and we'll get the position and the instruction. Is it fair to call it that? Yeah, instruction, I guess. Maybe we'll call it, yeah, instruction's fine. I don't know why I'm wavering on that. I think it's just because in my head I'm conflating it with this one, which is actually just the, like, ACK or no-op or jump. But this is actually the tuple. Yeah, maybe we'll call this instruction tuple just to clarify that for myself. So we'll get here, we'll pull them apart to the instruction value. And so if the instruction is ACK, well, we're not going to change that, so we'll just, I guess, say next. Else, we're assuming it's going to be no up or jump. Maybe we'll actually, else if, can remove those surrounding parentheses. I don't need them here either. So if instruction equals no op, then we will yeah, it's like we want to create like a copy of the instructions by position and run that through follow instructions. Yeah, so I wonder, is there like a clone shallow copy? So if we have like one ACK for 2 nope 0, if we have that, nothing. Oh, this isn't a, so I need to open up console to actually run this. That's just the docs. So we run that. What doesn't it like? Unexpected comma. These are just key value pairs. What doesn't it like? Oh, because that's not a symbol. Okay. So that, let's just say this is first, and then second gets first.clone. So it's second. Okay. So if I say second dot it's taco, second, first. Okay, so I guess I can clone these. So I will say instructions by position, clone, temp instruction set. I'll say temp instruction set position gets jump, because we're changing the no op to a jump, and then we're using the same value. And then we call follow instructions with 0, 0, empty array, temp instruction set. And if that doesn't raise an error, then we have a solution. I have to do something pretty similar here for jump, which we will change to no ops. And then at the end, we have a similar kind of they shouldn't be here. Now, I do want to say begin and rescue from our, what did we call it? Infinite loop error. And so if we rescue from that, I think we just say next and go to the next one. Because that just means we've detected infinite loop. This isn't going to be our solution. Let's keep going. What's this if complaining about? That could be a guard clause. Okay. Sure. So eventually this will return something. Answer, and we'll spit out the answer. Yeah, I think this is a good attempt at a solution. Let's give it a run. We are running on the sample input, and so we expect to get an answer of 8. Undefined local variable method instruction, line 24. Instructions. Let's try that again. Oh, it does not like that. Line 24 still. Instructions. Oh, because we don't have this in our context. Okay. So we'll just instructions by position. Try that instead. 8. What in the world did it print here? Kind of curious what all those extra lines were for. If I run that again, that's my only puts. What's the answer? The answer is just going to be the result of oh, because I'm getting an array back. Maybe this should be like an each. Each. I can almost just return over the each at this point. Nope, doesn't like that. Does the each still give us 8? No, that returns map. I think we're onto the right thing here. I just have sort of bungled this first part, trying to rethink through it. Basically, we just want to iterate over the entire instructions by position until a point at which we've got to follow instructions that return something. Yeah, so it's almost like result, and then down here we say break out of the result. Yeah, it's almost like we want to do the same, like answer gets catch object. I want to use this throw catch thing again. That's kind of where I'm leaning. And we'll put out the answer, and if we, where's this going? That's that do. So if we get down here and we have a result, we're gonna, I guess, throw object result if result dot present. Oops. Catch object. Oh. Try a blank. See, here I am leaning on active support, and it's if result, not, let's try that. What are these things complaining about? Snake case, oh brother, yeah. Writing too much JavaScript. Cool. And then avoid double negation. Well, that's fine. 8. Okay. That feels a lot better. Let's use the big old sample input. I have to do a little more computation for this one. And, oh, that was pretty quick. Computers can execute instructions very quickly. So, is this our answer? All right, we got our second gold star for the day. Maybe we'll see you tomorrow for day 9. Thanks for watching.